Everyone, so this time we're gonna start proving from IV to VII today. So from IV to VII here. So the first problem, find all numbers x for which x minus 1 times x minus 3 is greater than 0. So it's asking us to see when is the product of two numbers positive. Okay, then we know that a times b is positive if a and b are positive, but also minus a times minus b is positive, right? If a and b are positive. So we know that if x is greater than 0 and x minus 3 is greater than 0, by closure, the product of the two are also greater than 0, right? At the same time, we know that when x minus 1 is less than 0 and x minus 3 is less than 0, then this also implies that the product of the two are greater than 0, right? This is left to be proved because we can ask ourselves why. Why? We'll get to that later. But let's just assume that this is true, right? And then if x minus 1 is less than 0, that means x is less than 1 and x is less than 3. But then again, this is also equivalent to saying x is less than 1. Right? This again means that x has to be less than 1, because if x is greater than 1 but less than 3, then x minus 1 is positive while x minus 3 is negative. So the product of the two is less than 0. At the same time, we can also see what the range of values are allowed here on the first statement we made. When x is greater than 1 and x is greater than 3, that means that x needs to be greater than 3. Yeah? So by these two, we know x is either have to be greater than 3 or it has to be less than 1. That way we satisfy x minus 1 times x minus 3 is greater than 0. Okay? Second problem. Okay, so before we get to the problem V, let's see if we can prove this one. If A and B are greater than 0, then wait a second. If A is less than 0 and B is less than 0, then A times B is greater than 0, right? This is the statement that we had to prove before jumping into saying that X minus 1 times x minus 3 is greater than 0 when x minus 1 is less than 0, and also x minus 3 was less than 0. So to say that those are true, we need to prove this fact first. So how do we get there? So since a is less than 0, that means minus a is in P. Also minus b is in P. And therefore, we know that minus a times minus b is in P. That means that a times b is in P, right? So this is the exact statement that we wanted to prove. Same thing. So what AB is in P means that AB is actually in fact greater than 0, right? So we proved it. All right. So let's get to problem V. Find all numbers x for which x squared minus 2x plus 2 is greater than 0. All right. So what does this quadratic equation reduce down to? Can we factor it? Yeah, let's see if we can do that, right? So first of all, this quadratic equation can be factored into x plus 2 plus square root of minus 4 plus actually, sorry. 1 second. Okay, by quadratic formula, it's negative b plus minus square root of b squared minus 4ac, which is minus 8. Oh, wait a second. And then over 2a, which is 2. Okay, so we have the square root of, we need square root of 4 minus 8, which it doesn't have a corresponding real value, right? So this is same thing for the 2 minus square root of minus 8, minus 4. So there's no real solution for this as well. So I think what we need to do is actually prove that this is in fact is always greater than 0, right? How do we do that? Let's see. First of all, x times x minus 2 is greater than 0. When? When is it greater than 0? When x is greater than 0 and x minus 2 is greater than 0. And also x is less than 0, and also x minus 2 is less than 0, right? So there are two cases. One case here, second case there. So what these compound statements mean is that when x is greater than 2, this inequality is satisfied. And also when x is less than 0, these inequalities are satisfied. So we have two cases where x is greater than 2, or x is less than 0, which makes this product greater than 0. Okay? So in both of these cases, x times x minus 2 is greater than 0. So in both of these cases, x times x minus 2 plus 2 is also greater than 0. But what if x is less than or equal to 2, but also greater than or equal to 0, right? What if x is between 0 and 2? Then actually proving this is not very easy, I thought. I'll get back to you when I solve this. Be right back. Okay, so 5 was pretty straightforward. Let's think about it this way. We have this equation, x minus 1 times x minus 1. This is always greater than or equal to 0. So the reason being is that suppose that this is positive, right? Then obviously by closure, this whole thing is in positive. But also when this term is negative times negative positive. So by what we just proved before, this is also positive, right? And we need to consider how this expands to. So this is x squared minus 2x plus 1, right? Well, what we have over here in v is x squared minus 2x plus 2, which is greater than or equal to plus 1, right? Hence, it's also greater than 0, greater than or equal to 0. So for all x squared minus 2x plus 2 is greater than 0. This equation is actually 0 when x equal to 1. But we don't need to consider the case where this is equal to 0, because this is always greater than 0. One second. What I wanted to say is the minimum of this value is 1 and is 0. And since the minimum, this whole thing is greater than this one, this is always greater than 0, right? So we need to prove. Actually, yeah, it is pretty intuitive. The product of these two numbers is 0. So that means that the minimum value of these is 0. Yeah. Okay, let's do this. So by formality, let's prove x minus 1 times x minus 1. The minimum value for all x is 0, right? Suppose there is, let's use contradiction. Suppose there's y, where y equals x minus 1 times x minus 1, and y is less than 0. Then we can consider the case where x minus 1 is less than 0, and x minus 1 is greater than 0. Or three cases equal to 0. Then here y is equal to a times a, where both are greater than 0. Then y is greater than 0, right? Here x minus 1 equal to 0. That means y is 0 times 0. That means y is equal to 0. Here y is x minus 1. Again, same thing. Plus times plus is also plus, so it's greater than 0. So in no cases y is in fact less than 0. So this is a contradiction. So the minimum value for all x is 0, because we know a case where x can be 0, which is that x is equal to 1. That is the lowest value you can get. Okay, so now let's prove x squared x plus 1 is equal to greater than 2. When does this inequality satisfy? Right? This is equivalent to saying x squared plus x minus 1 is greater than 0. But we don't really know when this is equal to or greater than 0. For example, if x is equal to 2, x squared is 4, x is 2, minus 1, 5, greater than 0. So satisfies, but we don't know when exactly, like the range of values of x that satisfy this. Okay, so let me get back to you real soon. Okay, so for problem VI, when x is greater than square root of 5, over 2 minus 1 over 2, and x is less than, x is less than negative square root of 5 over 2 minus 1 over 2, then this inequality are satisfied. And then in both of these cases, we know that x plus 1 over 2 squared is greater than 5 over 4. And then x plus 1 over 2 squared minus 1 over 4 minus 1 is greater than 0. When we expand this, it comes down to x squared plus x minus 1 is greater than 0. So for this inequality to be satisfied, we need to make sure x is greater than square root of 5 over 2 minus 1 over 2, and x is less than negative square root of 5 over 2 minus 1 over 2. All right. So now let's get to problem VII. Let me finish up erasing this. X squared minus x plus 10 greater than 16. When is it true? This is true when minus 6 greater than 0. This is true when x minus 3 times x plus 2 is greater than 0. This is true when x3 minus 3 is greater than 0, x plus is greater than 0. That means x is greater than 3 and x is greater than negative 2. This is true when x is greater than 3. So we found one case. Another case is when x minus 3 is less than 0 and x plus 2 is less than 0 too. This means that x is less than 3 and x is less than negative 2. This means that x should be less than negative 2. So we have two cases in which these inequalities are satisfied, which is one is that x should be greater than 3 or x should be less than negative 2. All right, thank you for watching. We'll get down to problem VII and IX and X in the next video. Thank you for watching. Bye-bye.